Kingfisher School of Business and Finance.
Together with my classmates, we will explore how planets move in space and how can we convert their rotations and revolutions into time units we understand here on Earth.
Before we begin, I hope you're all feeling wonderful, excited, and ready to learn in today's session. Make sure to stay focused and participate so you can fully understand the concepts we will discuss.
Now, do you have your papers and pens ready for today's lesson? If yes, that's great to hear. Let's start our session with a prayer. Would you like to lead us?
Dear God, we thank you for this day and the opportunity to learn. Help us focus, be kind, and do our best. Amen.
Thank you. That was a wonderful way to begin.
Before we move forward, can you share what we discussed in our previous lesson?
Excellent! We talked about the layers of the Earth. We learned that the Earth is made up of 4 main layers: the crust, mantle, outer core, and inner core. Each layer has its own unique characteristics. The crust is the outermost and thinnest layer where we live. The mantle is made of semi-solid rock. And the core, both outer and inner, is made mostly of metals, with the inner core being solid and the outer core being liquid.
Well remembered. Now that we refresh our memory, you're ready for our new lesson, one that will take us beyond our everyday world. So, let's get started by stating our objective for today's video tutorial.
By the end of this tutorial, you will be able to define rotation and revolution, differentiate rotation and revolution, explain time in its standard units, convert time measurements using the time zone week, and analyze how planets, rotations, and revolutions differ from Earth's.
Let's play a quick game to warm up. I'll name a planet and you guess how long a day or a year lasts there.
First one, Mercury. How long is one day on Mercury?
It's 59 Earth days. That's a really long day.
Now, how about Jupiter? Any guesses?
Just 10 hours? Super fast, right?
Now that you're energized and have an idea of today's lesson, let's dive right in and really start learning.
Have you ever noticed those tiny twinkling points in the night sky? The ones our parents introduced to us as stars and sometimes even planets. Have you ever dreamed of visiting one someday? That would be an incredible adventure, wouldn't it? Imagine traveling to a planet just like the astronauts and scientists who study the objects beyond our world.
Would you like to become an astronaut one day? That would be amazing.
But what exactly makes an object a planet? Do you have any ideas?
Indeed, according to the International Astronomical Union, for a celestial body to be classified as a planet, it must meet 3 conditions. 1. It must orbit a star, like how all the planets in our solar system orbit the Sun. 2. It must have enough gravity to shape itself into a sphere. 3. It must be able to clear its orbit of the other objects of similar size.
Excellent ideas, right? Planets are truly mysterious and fascinating to study. There are countless planets in the universe spans across different galaxies. And of course, within our very own solar system. But what makes our solar system so special?
Well, first of all, the solar system is our home. It's where our planet, Earth, belongs. And here's something incredible to think about. Earth is the only planet we know of that supports life. Scientists have explored and studied many planets, but so far, no other planet has shown signs of life the way Earth does. Isn't that amazing? It makes our planet truly unique.
But what exactly is the solar system? What makes it up? Is it just the sun and the planets? Or are there more things in space that belongs to our system?
Think about it. When you look up at the night sky, you don't just see planets. You see stars, moons, and maybe even comets and asteroids if you're lucky. Our solar system is made up of many different celestial bodies, and each one plays an important role in the way our system works.
So let me ask you, what do you think makes up our solar system? Can you name some of the objects that belongs to it?
The solar system is made up of the sun and all the celestial objects that orbits it. This includes planets, moons, asteroids, and comets. The 8 planets are divided into 2 groups. First, the inner planets: Mercury, Venus, Earth, and Mars. These are small, rocky planets that do not have rings. Second, the outer planets: Jupiter, Saturn, Uranus, and Neptune. These are large gas giants, mostly made of gas, and they all have rings and many moons.
Now, have you ever thought about time? We use it every day. We wake up at a certain time, eat lunch at a certain time, and go to bed at night. But wait, have you ever wondered how time is measured?
Time isn't just something we use to schedule our day. It's actually a fundamental part of how the universe works. Scientists measure time in different ways, using seconds, minutes, hours, days, months, and years. But where do these measurements come from?
Think about it. Why do we have 24 hours in a day? Why do we have 365 days in a year? These numbers aren't random. They are based on something much bigger than our clocks and calendars. They are based on the movements of our planets and the solar system.
Let's start about what is rotation and revolution.
Rotation is when a planet spins around its axis. For example, the Earth takes 24 hours to complete one rotation, giving us day and night.
Revolution is when a planet orbits around the Sun. Earth takes about 365 days to finish one revolution, which give us a year.
Here's a simple comparison. Rotation, spin on its axis, 1 day. Revolution, orbits the sun, 1 year.
Rotations happens faster. It is measured in hours or days, whereas revolutions takes longer. It is measured in days or even years.
We measure time in units: seconds, minutes, hours, days, months, and years. For example, 60 seconds is equivalent to 1 minute, and 60 minutes is equivalent to 1 hour.
24 hours for a day, 30 days for a month, and 12 months for a year.
Well done! Understanding time conversions can sometimes feel confusing, right? Especially when you're not sure whether to divide or multiply to change one unit of time into another. But don't worry, I have a fun and easy trick that will help you remember different units of time effortlessly. Let's go on a little imaginary trip to the zoo! Now, have you ever visited a zoo before? What animals do you usually see there?
Well, we remember, here's the time zoo. 60 snakes has 60 seconds, 60 monkeys has 60 minutes, 24 hippos has 24 hours.
30 ducks as 30 days, 12 mice as 12 months, and 1 yellow-eyed penguin as 1 year.
Now, how do we use this trick to convert time? With the following mnemonics flashed on your screen, can you guess how we will be going to use this?
You guessed it right. This time, zoo trick is used by starting to have a number and a measurement of time. Then look at the first letter of each animal's name. Each one stands for unit of time. S for snakes, which is seconds, M for monkeys, which is minutes, H for hippos, which is hours, D for ducks, which is days, M for mice, which is months, Y for yellow-eyed penguin, which is year. Next, identify the unit you want to convert from and the unit you want to convert to, and identify the animal it was associated to.
Here's how you convert time. If you go to the right in the time zoo, you divide. If you go to the left, you multiply.
Time is something we use every single day. We measure how long we sleep, how many minutes a game lasts, how many days are in a month, and how many years make up a lifetime. Knowing how to convert time units will help us in many real-life situations.
So, let's review. Can you recall the animals and the units of time they represent?
Let's convert 48 hours into days. Hours as hippos, days as ducks. Ducks are to the right of hippos, so we divide by 24. 48 divided by 24 is equal to 2 days.
Mercury rotates once every 1,408 hours. Let's convert that to minutes. 1,408 hours multiplied to 60 will be equal to 84,480 minutes.
Mercury revolves around the sun every 88 days. Converting that into months, 88 divided by 30 is equals to 2.93 months, or about 3 months.
Now, it's your turn. Find a partner or do this on your own. Explain the difference between rotation and revolution. Give examples of planetary times. Try converting Venus revolution into hours.
Venus revolution is 225 days. 225 times 24 is equal to 5,400 hours.
Now that we've explored the concept of time and how it relates to planetary motion, let's think deeper. Here are some questions to help us reflect on what we've learned. Number 1, what is the difference between rotation and revolution? Number 2, how does the length of a planet's day relate to its rotation time? Number 3, why do some planets have shorter or longer years than Earth? Number 2, how do you think time is measured in space, especially on other planets? Number 5, how can we convert planetary time, days, years, into standard time units like hours or minutes? Number 6, why is it important to understand time measurement beyond Earth, especially in space exploration?
Take a moment to think about these questions. Feel free to discuss your thoughts. Let's see how well we can connect with what we have learned today to the real world and beyond.
Awesome! Now, let's test our skills with a fun activity. Who's ready?
Let's have a quick quiz. Let us convert Earth's rotation, which is composed of 1,440 minutes, into seconds.
You can pause the video now and take a moment to solve it on your own. You can use what you've already learned or apply the Time Zoo trick to help you. Take your time, think through the steps, and when you're ready, press play again so we can go over the answers together. Good luck! I know you've got this!
1,440 multiplied by 60 is equals to 86,400 seconds.
Convert Mars revolution into minutes. I will give you 10 seconds. To check your answer, 687 days times 24 hours, then multiplied to 60 minutes equals to 989,280 minutes.
For your task, make a 2-minute video explaining rotation and revolution. Include visuals, drawings, or animations. Submit your video by Monday.
That wraps up our tutorial on time conversion in the solar system.
We hope you learned something exciting about how time works in different planets.
Thank you for watching. See you next time.